When it comes to the three stages of agent development I mentioned, their key differences or defining characteristics lie in several core dimensions: cognitive capability, reasoning and prediction, spatial perception, autonomy, generalization, and self-evolution. Specifically, specialized agentic AI is marked by its deep expertise in narrow domains. They're built to handle well-defined tasks in specific fields, for example, programming or NLP applications like translation, chatbot, or customer service. Within their predefined domains, they can deliver remarkable efficiency and accuracy, often surpassing human experts. However, their capabilities are strictly confined to their specialized areas, lacking cross-domain transfer learning or problem-solving abilities for new types of tasks. Their logic is manually orchestrated, with no genuine understanding or reasoning or planning capabilities. Currently, these agents rely on large language models, think in linguistic forms, and operate primarily in the digital world without spatial perception or direct interaction with the physical world. General agentic AI has not yet been realized. It is envisioned to possess human-level comprehensive cognitive abilities, capable of understanding, learning, and applying knowledge across diverse domains and tasks, reasoning, planning, solving complex problems, abstract thinking, and creativity like humans. The core feature of general agentic AI lies in its fully autonomous reasoning and planning capabilities, rather than simply executing predefined logic or workflows. It can learn independently and adapt to unfamiliar, untrained scenarios, grasp physical laws, understand the spatial structure and relationships among objects, and predict the outcomes of actions. It is also expected to interact with the physical world through multimodal capabilities and possess the ability for continuous learning and self-evolution. Superagentic AI remains a hypothetical, higher-dimensional form of intelligence that goes far beyond general agentic AI. It is envisioned as possessing cognitive capabilities that vastly exceed even the most intelligent humans across nearly all domains. Unlike the quantitative progression of becoming simply smarter, superagentic AI represents a qualitative leap in the very nature of cognition, embodying forms of intelligence and consciousness that may be fundamentally different and unpredictable from a human perspective. In areas such as creativity, wisdom, complex problem-solving, and the speed of self-evolution, its capabilities could operate entirely beyond the boundaries of current human understanding. The emergence of such an entity could fundamentally redefine the concept of intelligence itself and potentially challenge humanity's role as the primary cognitive force on the planet. Each type of AI agents requires distinct key technologies to achieve its ideal state. Specialized agentic AI has advanced rapidly in recent years, largely driven by progress in generative AI, especially the development of large language models and reasoning systems. These technologies have enabled valuable applications in areas like code generation and customer service. However, challenges such as limited deep understanding, occasional inaccuracies, low reliability, and high computational costs have prevented widespread adoption across domains. Overcoming these issues will require breakthroughs in deep semantic understanding, advanced reasoning and planning, and the ability to handle ultra-long context. Efficient and reliable reasoning remains a major bottleneck. While current models are trained on long-text chain-of-thought data, they essentially perform text pattern matching, exposing limitations in their actual reasoning capacity in real-world scenarios. In addition, existing computational strategies lead to high resource consumption and response latency, with poor performance on complex or unfamiliar tasks. Achieving true autonomous planning and execution will require not only advances in reasoning, but also improvements in algorithm efficiency and hardware optimization to enable scalable, cost-effective deployment. The core challenge for general agentic AI lies in endowing machines with genuine human-like understanding, reasoning, and cross-domain learning abilities. This requires foundational theoretical breakthroughs, enabling AI to master and apply common-sense knowledge, perform deep causal inference, and achieve advancements in spatial intelligence, world models, and continuous self-learning. Spatial intelligence equips machines with the ability to perceive, comprehend, and reason within 3D environments. Beyond mere object recognition, it facilitates an understanding of spatial configurations, environmental context, and the consequences of physical interactions. World models provide a structured approach for agents to learn and represent the physical dynamics, spatial attributes, and causal relationships within real-world environments. This capability underpins spatial intelligence, allowing agents to reason about space, anticipate the outcomes of their actions, and make more informed autonomous decisions. World models provide critical modeling support for embodied intelligence, enabling intelligent entities such as robots to navigate and act autonomously in the physical world. Meanwhile, continual self-learning is also essential for general agentic AI, as it allows agents to continuously acquire knowledge through interactions with their environment. This ongoing learning process enables the agent to improve its intelligence over time and adapt to new, unseen scenarios, significantly enhancing its generalization capabilities and overall versatility. Super agentic AI's defining feature is its goal-directed infinite potential with magical capabilities relative to humans. Building on the foundation of general agentic AI, it would require the ability to recursively self-improve, enabling exponential enhancement of its own intelligence. Furthermore, it would possess an unparalleled level of control over the physical world. Its core capabilities lie in two fundamental aspects: the meta-capacity for recursive self-evolution and extreme control over the physical world. These traits enable rapid, exponential growth in intelligence, potentially leading to behaviors and goals that go beyond human comprehension and control. Realizing such capabilities demands a fundamental rethinking of what intelligence truly is, calling for breakthroughs not only in technology, but in the very theoretical foundations that define cognition. For now, super agentic AI exists primarily as a conceptual vision.